All right, so we're picking up today with question 26. We're going to work 26 through 45. It should take us about 20 to 25 minutes. We'll stop and explain a little bit of thing. Like I explained yesterday, I'm working these problems at the pace that you would need to work them on the ACT tomorrow. So you get kind of used to roughly a minute or a little over a minute for some of the more difficult problems is what you need to be spending. Now, don't stress too much on time. The important thing is that you try to see every problem and give yourself a shot to do it, answer it. All right, so 26 gives us a circle in standard coordinate plane, has a center at -1, 2. The circle passes through 2, 6. That's a point on the circle, right? Everybody understand what that means. Line segment AB is a diameter. What do you know about diameters of a circle?
Double the radius.
It's twice the radius. The diameter passes through the center. So look, this is a draw a picture kind of question right from the start. So we're going to draw a circle. I'm going to put the center right here. The center is -1, 2, and 2, 6 in relationship to that would be somewhere over here to the right. So I'm going to put it right here, 2, 6. That's A. That's C. So B has to be somewhere over here. All right. Now, if we were drawing, if this were in the coordinate plane, at this point, we might be able to come up with a good guess of which point it is, right? If we kind of say, where are we? -1, 2. Looks like the x-axis may be somewhere like right. This may be an axis there. We may have an axis like right here. We might be able to come up with a good guess what that point is, right? Any good guesses? Maybe that one, right? Just from drawing the picture. But if we look at this, this is a midpoint problem again. And I told you guys that all midpoint problems yesterday will work with this. But if we go from 6 down to 2, what do?
Subtract.
We subtracted how many?
4.
If we subtract 4 again to get to that point, what are we going to have? 2 minus 4 is -2, right? So that gives us 2 choices, this one or this one. If I go from 2 to -1, I subtracted 3. -1, subtract 3 more, we're going to get -4. All right? Okay. So, again, guys, for the concept of midpoint, here's what we need to think about midpoint. Midpoint is the average of the 2 points, okay? Midpoint is the average of the 2 points, but on the ACT, midpoint can almost always be figured out very quickly by graphing it. All right? So you would have guessed -4, -2, most likely, or -6, -2 could have been a possibility, but just by drawing a quick picture and graph and labeling the points, hey, the point needs to be over there. That's got to be one of those two. All right, next question. Which of the following expressions is a factor of x cubed minus 64? If you don't remember how to factor cubes, you're going to be guessing on this one. Which one would you guess?
A.
A is correct. All right. Now, factoring cubes, the first thing you do is cubes will factor as a binomial times a trinomial. Somebody tell me y'all remember a little of this. And the first parentheses is always the cube roots. The cube root of x cubed is x. The cube root of 64 is 4. The sign of the first parentheses is always the same. Okay? The next sign would be opposite, and the third sign is always positive. But we don't really need to work any farther than that. Just to show you quickly, the values in the 3 values in the next parentheses, you square the terms, you multiply the terms, and you square the terms. So you square this term and you get x squared. That's the wrong pen tool. If we square that term, we get x squared. If we multiply them together, we get 4x. If we square that term, we get 16. But this is one of those problems where you remember how to factor cubes or you don't, but you would have probably guessed the correct answer is x minus 4. Okay? A lot of reading here. The average of a list of 4 numbers is 90. Okay, great. A new list of 4 numbers has the same first 3 numbers as the original list. But the 4th number in the original list is 80, and the 4th number in the new list is 96. What is the average of the new list of numbers? Okay, this looks kind of confusing. How do you average things? You add them all together and then divide, in this case, by 4. Okay, so the numbers are the same, except on the new list we replaced 80 with 96. So how much larger is the new sum going to be? 16. It's going to be 16 larger. And if we divide 16 by 4, we get 4. So the new average is going to be 4 larger than the old average. Okay? Now this is just making sure that you understand the concept of what an average is. You add the things together, you divide by the total number, and then you're going to get the complete thing. Now I want to ask you a question. Have we touched a calculator? Have we even done any mathematics really yet? Okay. The ACT, a lot of the ACT is, do you understand mathematical concepts? Okay. So you would be thinking, oh, how do I do this? Setting up equations and that kind of stuff. You could do it that way, but you don't have to do it that way. This is just a question of, do you understand what an average is? This problem looks complicated because of all this stuff. Cut through the what it looks like. Never assume it's difficult because of what it looks like. The number A is located at negative 2.5 on the number line below. One of the following lines shows the location of A squared. So they're just really asking us if we know what negative 2.5 squared is. If you multiply negative 2.5 times itself, first of all, we're going to get a positive number, so it can't be any of these negative values, right? It's going to be 2.5 times 2.5. What's 25 squared? 6.25. All right. So it's going to be E. All right. Now that is a problem that you could punch into your calculator real quickly. You got to be careful though. If you punch negative 2.5 squared into your graphing calculator, it's going to tell you negative 6.25, and it's going to be correct. You have to use parentheses anytime you're substituting values into your calculator. We're squaring a negative, which means we're going to get a positive, right? Easy question. Looks complicated, but it's not. All right, Maria ordered a pizza. About this time on ACT, you might be getting a little hungry. She might have made your mouth water. She ate 2 pieces out of 9. How do they cut a pizza into 9 slices? It's me. How do you cut a pizza into 9 slices? That's creative pizza cutting right there. I'm going to clean it up when I'm done. I just didn't have time to stop. How many pieces are left? Because that's immediately what we need to be thinking. 7 out of 9 are left, right? So if 2/9 is gone, 7/9 is left. And that's going to be important because she's going to give the remaining pizza, which is 7 pieces out of 9, to her brothers. What fraction of the whole pizza will each of her brothers receive if they share the remaining pizza equally? Will they each get what fraction of it? They get 1/3 of it, right? So what is 1/3 of 7/9 is what we're looking for here. So each brother would get 7/27 of the pizza. Still nobody's answering me how you slice a pizza into 9 slices.
Do they have to be equally?
No, they wouldn't. I mean, she took a piece of bite or something and then put it back or something like that. All right, y'all okay with that? So 7 out of 27 is where we are. The number 1001, here's a number theory question. I like these questions. The number 1001 is the product of prime numbers 7, 11, and 13. That means if you multiply 7, 11, and 13 together, you get 1001. Knowing this, What is the prime factorization of 30,000 and 30? Now, any idea what they multiplied 1,001 by to get 30,000 and 30? Looks like they probably multiplied it by 30, right? So if they added a factor of 30 to this, then our new factors, our new prime factorization is going to be our old prime factorization times the prime factorization of 30, which is 6 times 5. So there's my new prime factorization that I'm looking for. You might not want to sit there. Yeah, sit in front of Carla K. All right, any questions? Any questions? Y'all good with that? All right, 32, the cluster problem. So now we've got 2 cluster questions. Let me tell you something. I'm going to show you a little trick here that I think you're going to appreciate before. On these cluster questions, you're always going to have all of this complicated stuff up here. Don't read it. Okay? First time you've ever had a math teacher tell you not to read it. It takes too long to read, and most of the time there's more extra information than there is information that you need. Okay? The cluster questions take time if you're going to read everything. All right? All right, so here we go. The only thing we really need from up top, we can know already, is trapezoid, right? That's the only thing we really need. But you can look at that and see that it's trapezoid. Look at the question that goes along with this. What is the area in square inches of the scale drawing of the park? What's the area of a trapezoid is what they're asking you. What's the area of a trapezoid? Here's one of those things you need to know. It's half of base 1 plus base 2 times the height. In other words, it's the average of these two values. Half of two things is their average times 16. So half of 68, right? Half of 28 and 40 is 68 times 16. That's 8 times 68. It's 480 plus 64. 544. Okay. Now, that might be something that you'd want to do a calculator with. You can't multiply that quickly. If you ever want to multiply that by quickly like that, swing by my office and I can show you some tricks on how to do that kind of thing. Now, keep in mind, we still haven't read the top, right? Look at this one, 33. Makia's proposal includes installing a fence on the perimeter of the park. What is the perimeter in feet of the park? Well, perimeter is the distance around the outside, right? So we got 40 plus 16 plus 28 plus this side right here. Okay? Now, this one is a little bit more advanced. If you were going to skip one of the cluster questions or guess, you might take a guess at this point and move on and come back to it later. But the way you finish solving this is you create a right triangle right here. Okay? So this little piece of this right triangle would be 12. Right? Because this is 28. The height is 16. So we got a 12 and a 16. All right, going back to yesterday, in a right triangle Pythagorean relationship, we always want to look for 3, 4, 5. Right? This is 4 times 3. This is 4 times 4. This is 4 times 5. Now, you can do the Pythagorean theorem if you want to, but every 3, 4, 5 ratio is going to work. So anytime you see a 4 times 3, 4 times 4, that's got to be 4 times 5. 3, 4, 5 is the ratio of the smallest integral Pythagorean triple. So that's 20. Add up all the sides and we get our perimeter, right? Now again, that problem, if you're going to skip one of the cluster problems, that might be the one that you skip and come back to later. Third one. The length of the south side of the park. I'm sorry, we didn't finish that, did we? It's 40, 56, 84, 104. 104 is the correct answer. That might be what you would have guessed. That would have been the good guess.
So that's how it was 20?
20. Yeah. Because, and let me slow down a little bit and do that. If you were going to do it by...
To plug in 1.5, because it says in feet, it's 1 inch times 1.5.
You know what? You were exactly right. We didn't scale it, did we? Okay, so 1 inch is 1.5. What is the perimeter in feet? We messed up. In feet. So the inches here would give us, let's go back to that. So this was 12, this was 16. And if you use the Pythagorean theorem straight up, 12 squared plus 16 squared equals c squared. That's 144 plus 256. 400 equals c squared, which means c is 20. So there's 104 inches in our drawing, but each inch is 1.5 feet, so you'd have to multiply that by 1.5, and you get 156 is the correct answer. Good catch, Tyke. I was rushing through that a little too quickly to see that, and every time I take an ACT, I'll make a mistake like that. Keeps me from being perfect on the math. Simple mistakes. Last question. The length of the south side of the park is what percent of the length of the north side? Now, y'all remember is over of equals percent over 100. Y'all remember that simple ratio? That's what this is. The length of the south side of the park. What's the length of the south side of the park? 40. 40 is what percent of 28? That's what this question is asking. Can you see that? The length of the south side of the park is 40. Just replace that with 40. All this. Length of the north side, 28. So then you can use is over of equals percent over 100. And that's something that you hopefully y'all remember that. It's something that you used for a long time. Cross multiply, you get 28x equals 400. And then what else? Divided by 28, we get x equals 400 divided by 28. Something doesn't seem right.
Is it supposed to be 4,000?
4,000. Thank you. 4,000. Who said that? Well done. Then divide by 28, you get x equals what?
H. 142.857.
142.857. Okay. All right. Now, time out. Okay, we're off the pace. Now, we did that in a pace. We stopped and talked a little bit, but we did those three questions in a pace that you could have completed those. But let's look at all the useless information that they gave us up here. All this merry-go-round stuff, all these circles, the slides. Did any of that come into play? No. None of it was even in the question. Okay, so go to the question first on these clusters. It's going to save you time. All right, we're fixing to do another cluster. If you got a question, put a little asterisk there, and we'll come back in just a second. This one has even more reading, right? Looks really, really complicated. I'm going to tell you on these cluster questions what's the piece of advice I gave you. Don't read the information. Go straight to the questions, and then go get the information that you need. Here's the first question. Mr. Smith plans to build a 3-foot walkway around the outside of this cabin, as shown in the floor plan. What will be the area in square feet of the top surface of the walkway? Okay, what they're asking us is, And they even shaded it for us, which is nice, right? They want us to find the area of this shaded region that's all the way around the outside of it. Okay? That's what they're asking. And we don't need any of that information up top. We need to take the area of the big rectangle, right? And we need to subtract away the area of the house, the rectangle inside. Now, the tricky part of this is, so we're going to do 24 times, they gave us a 24. That's nice of them. 30 by 36 is the area of the big rectangle. And we're going to subtract away, what's the 24 by 30. That's exactly right. So that's the part they didn't give us, right? Because this is 3 feet on each side. I got 3 feet here, and I've got 3 feet here. The inside measurement of the house here is 30. Okay, so when you multiply that together, 30 by 36 minus 24 by 30, what do we get? Somebody have it? Nobody's. 360 is what we get. Okay, if you do those, can we confirm that? It's 360? Okay, so 360 is what we get. 360 square feet. Okay, next question. Mr. Smith will install a ceiling fan in each room. We might stop and look over there and see how many rooms there are. 3 rooms, all right? 3 ceiling fans. And she will place curtains over the 4 windows. No, we don't even have to count those. Each ceiling fan has a price of $52. Okay, so that's 3 times 52. The price of the curtains for each small window is $39.50. Go over to the picture. How many small windows do you see? You got 1, 2, 3 small windows. So there's 3 $39.50s. Price of the curtain for the large window is twice the amount of the small window. There's 1 large window, and it has a price tag of whatever 2 times $39.50 is. What is that? $79? Based on this information, which of the following values is close to the total price Mr. Smith will pay for curtains and ceiling fans? Again, have we used any of the information that they gave us in the drawing? And almost always you don't have to. We might have missed that 1.5 feet thing, but they reminded us in that question, didn't they? We just walked past it. Okay, so we get a total price of what? 350 something?
Yeah.
Okay. Now keep in mind they say what's the closest price. You may not find the exact price there. We'll find the one that's closest. Last question. Mr. and Mrs. Smith plan to roof the cabin on 2 consecutive days. Assuming that the chance of rain is independent of the day, what is the probability it'll rain on both days? Now we're looking for information about rain at this point. It's right down there at the bottom, right? There's a 20% chance of rain each day. Now, this is one you're going to know or you're not going to know. Independent events, to find the combined probability, you just multiply them together. If it's going to rain this day and rain this day, the probability of that happening is the probability multiplied times the probability. So what this probability is going to be 0.2 times 0.2, which is 0.04. 2 days, 2 probabilities, multiply them. Independent is the important word. You're not going to have any probabilities that aren't independent probabilities on the ACT. That's more complicated statistics than they ask. Now let's go back to the original problem. I want to show y'all something. Did we use any of this information? Did we use any of this information? Okay. Don't get bogged down in all the details that they give you on these cluster questions. Jump straight to the questions. Okay? All right, let's move to the next question. Which of the following expressions, when evaluated, equals an irrational number? This is asking us to know the definition of an irrational number. What is an irrational number?
Continues on verbally in
Not a pattern.
Right. It includes non-repeating, non-terminating decimals, which are the square roots of non-squares. So, square root of 7, square root of 2, square root of 3, square root of 5. Those are irrational numbers. Okay? Which of these numbers will remain irrational when you simplify them? Okay? What's 2 over 8? That's the square root of 1/4, which is 1/2. 8 over 2, square root of 4, which is 2. Obviously, if we square a square root, the square root just goes away. That's the square root of 16, which is 4. This is the only thing that will stay irrational if we do it. Now, you could probably jump right down to the bottom and say, square root of 2 is an irrational number. Can you even add it to the square root of 8 and make the square root of 2 go away? Remember, the only way you can kind of get rid of a radical is by multiplying it by itself or its conjugate. Okay? Next question. A line through the origin and 10 over 4 is shown below. The acute angle between the line and positive axis has a measure of theta. What is the tangent of this angle? Tangent of this angle. All right, so you need to know, for this problem, good old tangent is the opposite side, opposite leg divided by the adjacent leg. And all you got to do, guys, is drop a triangle in this thing right there. The height of this triangle is 4. Base of the triangle is 10. Tangent of theta is the opposite leg divided by the adjacent leg. So the tangent of theta is 4 over 10, which simplifies to be 5/2. Sine is opposite over hypotenuse. Cosine is the adjacent leg over the hypotenuse. The tangent is, what did I say? Oh, my goodness, yes. My cold medicine's kicking in on me this morning, y'all. Still not feeling real well. 2 over 5. 2 over 5. I gave the cotangent, right? If you flip it, cotangent is the reciprocal of tangent. So, yeah, 4 over 10 simplifies to 2/5. Good? Sine, opposite over hypotenuse. Cosine, adjacent leg over hypotenuse. Tangent, opposite leg over adjacent leg. All right, next question. The equation absolute value 2x minus 8 plus 3 equals 5 has 2 solutions. We know that most absolute value equations have 2 solutions. Those solutions are equal to the solutions to which the following pairs of equations. Now, absolute value equations always split into 2. That's a fact that you've been taught. But they don't split into 2 until you get the absolute value by itself. So the first thing you would do to solve this equation is to subtract 3 from both sides, right? And then you would split that into 2 different equations. Who can tell me what the equations would be? 2x minus 8 equals 2, or 2x minus 8 equals negative 2. That's exactly right. It's K. Here's what they did that's kind of different, right? They moved the negative to this side of this equation. But couldn't you whittle it down? Right? This can't be that one. Can't be that one. Can't be that one. Is this... No way that's the same as that. So it's got to be this one that's the same as that. But you at least give yourself a 50-50 chance just by subtracting the 3 and getting a 2 on both sides. Number 41. Number 41. The frequency chart below shows cumulative frequencies. Ms. Hernandez, a science student whose tests fell within a certain score range. All test scores are whole numbers. Now, if you've never read a cumulative frequency chart, this might be a little complicated. It's really pretty easy, though. Score range, 12 students scored between 65 and 70. So the next range adds which values? 71 to 80, right? How many additional people scored in that range? 1, right? It only added 1. Then we add 6 in this next range, and then we add 2 in the next range. So how many people scored between 71 and 80? Only 1 person. So that's how you read a cumulative frequency table. Okay? Between 65 and 70, 12 students. We add the next 10 numbers, which is 71 to 80. It only adds 1 student. All right? Next question. The number of decimals, D, produced by an audio source can be modeled by the equation D equals, that's decimals equals 10 times the log of I over K, where I is the sound intensity of the audio source and K is a constant. And K is just a number. How many decimals are produced by an audio source whose intensity, right? Intensity, that's I, equals 1,000 times K. Now this is really a complicated looking problem, but it's a formula. We're looking for values to plug into the formula. They gave us a value right there. I is 1,000 times the value of K. So I'm going to take this value, plug it in right there for I. D equals 10 times the log. And this is a calculator problem if you don't know how to operate with logarithms. 1,000 K divided by K. What happens to the K's? So 10 times the log of 1,000. Log of 1,000. Calculator. If you plug this into your calculator at this point, 10 times log of 1,000. It's going to tell you that the log of 1,000 is 3, and 10 times that value is 30. I'll show you in a second. There's a log button. Now, that's right. See, log has a base 10. What this is asking, log of 1,000 is asking, y'all listen real quickly. Log of 1,000 is saying, what power of 10 is 1,000? That's what it's asking. What power of 10 is 1,000? The third power of 10. So log of 1,000 is 3. 3 times 10 is 30. And if you know logs real quickly, then you can go straight to the 3 and the 10 and the 30 and never have to touch your calculator. Okay? But that's a little advanced for juniors. That's going to be a pre-cal or a cal skill where you really get that comfortable with logarithms. 2 more and then we're done. 43. Mario plays basketball on a town league team. The table below gives Mario's scoring statistics for last season. How many points did he score playing basketball last season? He made 75% of his 1-point throws. What's 75% of 80? Now you could do that on a calculator, 0.75 times 80, or you could know that it's 60. So he made 60 1-pointers. Right? He made 90% of his 62-point goals. That's 54 2-pointers. And he made 25 of his 60 3-point shots. 25% of 60, 1/4 of 60 is 15 3-pointers. That's 45 plus 108 plus 60. 105 plus 108, 213 points. The key here, guys, is understanding is telling us 75% of. What does of always mean in mathematics? Multiply, right? So 0.75 times 80 is 60. 0.9 times 60 is 54. 0.25 times 60 is 15. And then you multiply it by the number of points, and you're good to go. So if you don't know anything about basketball, this kind of question would be difficult. You know. All right. The graph of y equals absolute value of x minus 6 in the standard coordinate plane, which the following transformations, when applied to the graph of y equals absolute value of x, results in the graph of y equals the absolute value of x minus 6. So what they're asking you to do is does this move it right, does it move it left, does it move it up, or does it move it down? Okay. Now, there's a long way to do this. You could plug these two functions into your graphing calculator and see what happens. That takes a minute. I want to show you a quick kind of way. Anytime they give you a transformation problem, take the new value and set it equal to 0. That's a really easy equation to solve, right? X minus 6 equals 0 if x is positive 6. Okay, so this is positive 6. X is positive 6. X is positive 6 means we move 6 to the right on the x-axis. Okay, so if they gave us something like the absolute value of x plus 2, if we find the new 0, right, find the 0, x plus 2 equals 0 means x would be left 2, right? Okay, just find a new 0. Last question. We ran a little over. Toby wants to find, I tell you what, we're going to pause and we'll pick up here tomorrow.